Hey there, Method students. In exercise 2C, we're now looking at some linear coordinate geometry, which essentially just means linear graphs. That was a big topic in year 11, and even you did a lot of this in sort of year 9 and year 10. There's a bit to remember. This sort of section here has just got a summary of some of the bigger formulas. We'll run through this quickly, but obviously you have this as a handout, so look back at this when you're doing your questions, particularly for things like distance and midpoint and perpendicular lines where you know there's a formula that applies. You can double check this sheet to make sure you've got it right. So essentially, our general form of a linear equation we know is y equals mx plus c, so you're going to use that idea a lot, where m will be the gradient, c is the y-intercept. We also have things like when we calculate gradient, we use sort of rise over run, but essentially our formula is m equals y2 take y1 over x2 take x1. It's a formula we've used a lot, but people still make mistakes with it, so use it carefully. It's also worth knowing, it doesn't happen heaps, but you do sometimes calculate the gradient using gradient equals tan theta, where theta is the angle formed with the positive direction of the x-axis. That's a formula that sometimes people forget because we probably don't use it a lot, but essentially what it looks like, and I should have put a picture on the notes, but if you've got a straight line like that, the angle that the line forms with the positive direction of the x-axis is what we're calling theta, and you can calculate the gradient. If you know that angle, you can calculate the gradient by doing tan of theta. Some other formulas we need to know. So if you're trying to find the equation of a straight line, if you know the gradient and you know a point, you can use the equation y minus y1 equals m times x minus x1. I know a lot of people would probably prefer to use y equals mx plus c and substitute values into that, which is perfectly fine as well. Also, parallel and perpendicular lines. So parallel, if two lines are parallel, it means they have the same gradient, so m1 will equal m2. If two lines are perpendicular, then one gradient is equal to the negative reciprocal of the other one, which essentially just means m1 is equal to negative 1 over m2. We've also got our midpoint and distance formulas here. So midpoint, if you've got two pairs of coordinates, the midpoint is just add the two x values together and divide them by 2. Add the two y coordinates together and divide them by 2. Essentially, the midpoint just finds the average of the x coordinates and the average of the y coordinates. And the distance formula, which actually comes from using Pythagoras' theorem on the Cartesian plane, is that distance will equal the square root of x2 take x1 squared plus y2 take y1 squared. The distance formula is just calculating the hypotenuse of a right-angled triangle, which is why when you look closely at it, you can actually see, using Pythagoras' theorem, that it is just an application of a squared plus b squared equals c squared. All right, let's try an example. This won't cover all of those rules, but it'll cover quite a few of them. So this question says, for the line 4x plus 6y equals 12, calculate or determine the gradient. So I think easiest way to do that would just be to rearrange the equation to get it in y equals mx plus c. So we can take away the 4x from both sides to get 6y equals negative 4x plus 12. Divide both sides by 6 to get y equals negative 4x on 6 plus 12x on 6. Simplify that. Negative 2/3 x plus 2. And now we can see that the gradient will be negative 2/3. So that's a D. G, gradient, equals negative 2/3. Sketch the graph over the domain negative 3 to positive 3. Okay, so what we want to know, we have a sense of what this graph will look like, but we also have to be mindful that the graph needs to start at negative 3 and finish at positive 3. So if we use this grid as accurately as we can, didn't have numbers on it, but let's call that negative 3, 2, 3, let's call that positive 3. Then that gives us the domain of the graph that we're supposed to sketch over. We know that the graph itself will have a y-intercept at 2. We might want to work out where the x-intercept is, and that can be a good way to sketch the graph. So x-intercept, let's let y equal 0. And you can use either version of the equation. I'm going to use the initial one because I think that's slightly easier. So 4x plus 6 times 0 equals 12, which just means 4x equals 12, and so x equals 3. So there is actually an intercept at x equals 3. Now, looking carefully at the domain, it was -3 not included, +3 included. So that x-intercept will go here. Did I bring a ruler to do a nice straight line? I would always tell you guys when you're doing your graphs to use a ruler. Phew, I've got one, lucky. All right, so now we know the x and y intercept. We can actually rule a straight line. Knowing that the graph needs to have an open circle, oh, got off camera there, open circle at that end of the domain. So that there needs to be an open circle. Now you typically would label your endpoints with coordinates. So we've got 3, 0 there. We should label the y-intercept as well, 0, 2. What we don't have, and apologies, there's not much space on the page here to work, is the y-coordinate of this point. We know that the x-coordinate is -3. So to find the y-coordinate, let's sub x equals -3 into our equation. Might just use some working space down here. So when x equals -3, we get 4 times -3 plus 6y equals 12. So -12 plus 6y equals 12. Hopefully you can still just see that on the screen. Add 12 to both sides, we get 6y equals 24. Divide both sides by 6, we get y equals 4. So when x equals 3, x equals -3, y equals +4. So that's sketching a linear graph, good bit of revision there, but also good to think about domain, because often when you're asked to sketch graphs in methods, you'll be given a domain to sketch it over. So you have to pay careful attention to that and not just sketch the graph going forever in both directions. State the range of the graph using interval notation. Okay, so now we have the picture. Well, range is just the y values and we read them from lowest to highest. So the lowest y value on this graph is 0 and it's included. The graph is continuous up to this point here. The highest y value that we get to is +4 and that is not included because we've got an open circle at that point. Okay, determine the equation of the line that is perpendicular to the graph drawn and which passes through the point 2, 1. All right, so perpendicular, let's work out the gradient first. So I'm going to call this, let's say the original equation is like m1, or sorry, the gradient of the original equation is m1. So the original gradient was -2/3. So that means that let's call it m perp. We could just write m2 if you preferred, but the other gradient, the perpendicular gradient, is going to be -1 over the original gradient, which is -1 over -2/3. If you're dividing by a fraction, you can do your keep, change, flip. So -1 times 3 over -2. So that just becomes, our negatives cancel out and we just get 3 on 2 as the perpendicular gradient. So we now have the gradient of our perpendicular line. We need to find the equation of the line. And remember that if you know the gradient and you know a point, then you can sub those values in order to find the equation. Now, I said before, there are a couple of different ways that you can do this. In my experience, most people tend to like the y equals mx plus c method. So let's use that. So we're going to say the equation of perpendicular line is y equals mx plus c, and we're going to sub m equals 3 on 2. We'll also substitute from this point x equals 2 and y equals 1. Just going to box that working off there. All right, so 1 equals 3 on 2 times 2 plus c. 3 over 2 times 2, well, the times 2 and divided by 2 cancel out. We just get left with 3. So 1 equals 3 plus c. Take away 3 from both sides and we'll get c equals -2. And then don't forget to actually write your final answer. We now know the gradient of our perpendicular line. We know the y-intercept. So the full equation is 3 on 2x, take away 2.